Thank you very much, Betty, and thank you to the Heartland Institute for paying my way here. In fact, that's about all the money I've ever gotten from any private organization other than notable organizations like the World Wildlife Fund and the International Fund for Animal Welfare. Whether those are subversive agencies or not, I don't know. What I want to talk about, and I have to be quick according to Isaac here, is I want to talk about three things very quickly. Social cost of carbon, in other words, what's the basis for making decisions. I want to talk about the prospects for reducing global CO2. I'm assuming, of course, that there is going to be some CO2 or action. And in other words, what's trending. And then I want to talk about the economics of international agreements. I once wrote a book about, more than a decade ago, about climate economics, why international accords fail, in answer to Kyoto, and I've been proven right, but nobody's read the book. All right, the basis for deciding is this social cost of carbon. And we heard it talk about that a little bit earlier, but I want to elaborate on that a little bit because I thought there were some errors. One of the big errors is that they assume that these models are coupled onto a climate model. They're far from it, all right? They basically take some input from these climate models, and as you'll see in a minute. All right, the social cost of carbon is defined in a variety of different ways. One is that it's the damage done by emitting an additional ton of CO2 into the atmosphere. In other words, the marginal damage cost, or a net present value of the damage done from releasing a ton of CO2 today. All right, how's it calculated? Well, as we mentioned, it's calculated using the integrated assessment models. All right, and in those integrated assessment models, what you basically have to do is assume some kind of a damage function. And that's the big kicker, assume. All right, and now the big issue has come about these models has dealt with the discount rate. And I'm going to talk about that in a minute. But the bigger thing is non-market values. If you look at the Stern report, everybody talks about the 1% discount rate that they used, but it's really the non-market values that they used. In other words, the damages that don't show up in GDP. Those are calculated using a technique that we call contingent valuation, contingent upon something happening. All right, the contingent valuation method, or CVM. And if you read the book by Kahneman, Daniel Kahneman, Nobel Prize winning psychologist who got the Nobel in economics, his book, Thinking, Fast and Slow, he basically says that it's very, very difficult to get these kind of numbers. All right, but think of it this way. If I ask you, what are you willing to pay to have something? All right, you're going to give me one answer. But if I tell you, what are you willing to accept as compensation for avoiding dirty drinking water, you're going to give me a huge number, right? Well, that's basically what we're doing here. We're asking people, what are you willing to accept as compensation not to fry yourself? All right? And if I ask you that question, everybody in this room would say, oh, $1,000 or something. So then I sum it over all people and I come up with a humongous number. All right? Bit meaningless. Now, here's I got to remember that this isn't the only way that I'm clicking here. This is basically a schematic of what an integrated assessment model looks like. All right, my own area of interest of research is on mathematical programming models, and I build quite a few of them. But what you're basically doing here is you're maximizing the sum of welfare, all right, over a 100-year or more period. And what you're doing is you're discounting that every year. Now, how do we define welfare? Well, we could define it as GDP. We can also define it as utility. All right, so GDP can either include just GDP, or it can include all these so-called non-market or environmental values. All right, then you have these technical and other constraints. So these are the big constraints in the model. So what I do is I run the model first with all these constraints in place, except for these ones here. All right, those are not included. I run the model, and that gives me these welfare measures, this measure here for every year for infinity with a high CO2 scenario, or if you like, business as usual, whatever you want to call it. All right. And the decision variable here is this CT, which is consumption, but it could also be investment, that kind of stuff. Now, as soon as I bring these in, all right, I get this damage function here, which is defined this way. All right, it's a function of temperature. So you'll notice that it's a quadratic function in this one. Nordhaus uses a quadratic function. I think Richard Toll uses a quadratic function. I don't know what the Page model does. Nordhaus is dice, Toll is, I think, fund. All right, but you'll notice that the higher this number, the greater the change in this temperature, this becomes a smaller and smaller ratio, which means you get a bigger and bigger damage. This number becomes smaller and smaller. All right. Now, this temperature is a function of CO2 in the atmosphere and emissions. All right. Now, where does temperature? You can also take temperature from a climate model, but you don't have to. All right. It can inform you, whatever. Now, so I've run it the first time to get this. Now, I've run it a second time with a certain amount of CO2 entering in. And I run it a third time with 1 shot of CO2, 1 megaton, let's say. All right. And the difference between the second and third answers is my social cost of carbon. So basically what I'm doing is I'm tuning a bunch of different knobs. And if you tune the discount rate knob, all right, and Nordhaus uses 6%, you get a social cost of carbon of $11. US government uses 3%, you get $33. Stern used something less than, closer to 1%, you got $200. All right, but it's really these non-market values that are the big thing, and it's basically those kind of things that Stern was looking at. All right, now to give you some idea of the non-market values, you'll notice here, this is a recent International Monetary Fund study. According to the International Energy Agency, total subsidies to fossil fuels in 2013 amounted to $548 billion. Okay, that's basically the difference between the price at the pump that they should be paying and what they are paying. And that's occurring mainly in countries which are oil producing and countries like Egypt and so on. But then the IMF says, well, let's put these environmental damages on, and they calculate these pollution, congestion damages and all that kind of stuff, including traffic accidents, and they come up with $2.8 trillion. And then you add in global warming, which is based on the social cost of capital. You add another 1.1 billion, and then this other category, and they come up with a total market value of subsidies equal to $4.3 trillion per year. All right? These are the kind of numbers that EPA is using and all that kind of stuff. Well, that's an incredible 6.4% of global GDP, or if you knock out the actual subsidies, it's 5.7%, which to me is just a ridiculous number. And the only way you can get it, of course, is through these non-market valuation surveys. Okay, what are the prospects for reducing global CO2 emissions? Well, I have 5 theses here. First, efforts by rich countries to stop reliance on fossil fuels and slow the atmospheric buildup of CO2 will be swamped by increasing emissions from developing countries. Let's see here, we have China, all right, and we look at coal consumption in China, and this is up to 2012. Well, you can see the picture here. The red line is the U.S. No matter what the U.S. does, China is going to outswamp them, all right? No matter what anybody does, all right? The only thing we're worried about is, pardon me, I got the wrong, trying to juggle 3 things here. This is the U.S. Guess what country that is? India, coming up, all right? They're going to expand coal production by some trillion gigawatt hours, and even the Chinese are going to be building, despite the fact that they're building a lot of renewable, nuclear, and everything else, gas, they're still going to predicted to be putting in an 800 megawatt power, coal-fired power capacity every 10 days for the next decade. All right. Okay, now if I go back, number 2, efforts to control CO2 emissions will be carried out on the back of the most vulnerable. All right. Number 3, wind, solar, all that kind of generation isn't going to do it. Nuclear energy is the only way out, and we're going to have international agreements. Whether Paris goes or not is going to really depend on the Americans. If it goes, one thing you can be guaranteed of, it's going to fail. I've been told I have very little time. This slide tells you that the reason why coal is popular and why gas is becoming popular, it's got to do with prices. This is Germany, all right? Germany relies on coal, the black and gray lines. Black is lignite, gray is regular coal. The green, wind and solar, are very small, but it turns out that the exports of German power to other countries is equal to what the wind and solar are bringing in. All right. We could talk about renewable energy, but I don't have the time. What's happened is the one point I want to give you is that a lot of the Europeans are going to coal-fire wood pellets. The Americans aren't. They can't, because their excuse for shutting down coal is related to pollutants, not to CO2. And if it's related to pollutants, you can't very well substitute that with wood. Okay, what about the economics of international agreements? Well, as an economist, I prefer a carbon tax, all right? And somebody out there is talking right now about how bad the carbon tax is. It's a cleaner instrument. The reason I prefer it is because I've been dealing with a corruption case, well, I call it a corruption case, where they were selling phony carbon offset credits, all right? And what happened is, as a result of this work, the Auditor General of British Columbia put out a report that ended up shutting down Pacific Carbon Trust, which was an agency that was selling these carbon offset credits to other government agencies. So the problem with carbon trading, all right, is that you get a FIFA effect, all right? Basically, you're creating rent-seeking opportunities, as we economists call it, and that opens the door to tremendous corruption, all right? We've seen it in Europe, for example, where the latest rumor I heard was that it was the mafia that built companies that were bogus companies, and they basically had all these carbon credits that they dumped onto the European Trading Exchange, and as a result, the trading exchange went basically belly up because the prices were too low. All right, this is an issue everywhere, and you can see here this is just control of corruption. Notice where Greece and Italy are; they're below that line. All right, China is below it. So what we're doing is we're basically going to be buying offsets from countries that are corrupt as can be. All right. This was the example I was mentioning. You can read about it in a paper I published in Forest Science very recently. I won't go through these other ones. I'll just end with the clean development mechanism. If you look at that, the argument had been that you're all familiar with the clean development mechanism that creates these carbon offsets, et cetera, and what basically happened there was the Chinese were being paid to destroy HFCs, all right? So they created a bunch of companies to produce them so that they could destroy them, all right? And I thought, nah, this can't be the case. Well, look at that. 52% of all the carbon credits that have been produced are from these destruction of HFCs and equivalents. All right, now, you want to know why your wind power industry ain't going to ever go anywhere in terms of jobs? Here are the number of projects, clean development projects, going to places like India and China and other countries, and in comparison, they're building wind turbines, and I don't even have solar on there, and you're paying for it, or we're paying for it as rich countries. Okay, my last slide is my conclusions. All right, number one, we do not know the value of the social cost of carbon. We probably never will. All right, it's made up under the guise of fancy programming. It's the kind of programming I like to do, but I like to calibrate it, and that's where the trick is. Number two is emissions of CO2 from fossil fuels will continue to rise in the future. It's unavoidable. We in the rich West can shut our economies down, and it won't do any good. The greatest threat that the UN climate people pose relates to the rent-seeking activities, and you get that FIFA effect. And finally, the consequence of 2 and 3 is that even if nations conclude an agreement to reduce CO2 emissions, it will cost a lot of money, but have no perceptible impact whatsoever on atmospheric CO2 concentrations and global warming if it's a real thing. Thank you very much.